Alright, hello and welcome back to the Theoretical Revolution. My name is Mark Hatfull and we have made it to video 4. This video is primarily focused on the topic of light. This is a good video because it addresses quite a controversial topic, something that's been well studied, yet there's a lot of mystery surrounding the topic of light, why it travels at the speed of light. So hopefully this one's not too controversial and doesn't upset too many people, but also this is a good one because it kind of ties together this whole theory. It makes principles of light make sense, and also makes the rest of my theory come together. So if you're still watching, thank you very much. I appreciate your time. Hope you enjoy this video. So the ring model. In my previous videos I discussed a basic concept between the balance of two forces, the inwards force of gravity, the outwards force of a pressure gradient or a vacuum. I then used this concept to explain the ring model, which is the shape and movement of the universe over time. I used these principles to then explain why I believe space is not a vacuum, but in fact that space is a medium of particles. So if you have not seen these first videos, please watch them in order. This video will make no sense to you whatsoever unless you've seen them in chronological order. So the universe. In my previous video I described that space is a mass of particles. I explained that the universe is a giant expanding mass, and therefore I believe that the universe itself is in fact a giant mass of space, which is both simultaneously expanding outwards as the universe increases in size, but also on a local scale due to galaxies and individual masses in the universe. It's also condensing due to gravity, so that the gravitational force of mass is pulling in space, and so masses like black holes or galaxies are actually condensing due to gravity and also pulling in space due to gravity, so gaining mass or increasing in mass as they pull in space or particles of space. So today's lecture, light, as I said before, an exciting topic, something that a lot of research has gone into, something that we still don't know a lot about. So in this video I'm going to talk about the properties of light. Very briefly, going to go over whether light is a wave, whether light is a particle, or whether light shows duality and has both properties of a wave and particle. I'll look into why we think the speed of light is constant, why it appears constant to us, and exactly how it does this. And then I'll look at why light bends due to gravity, so another concept which we think we already understand. We have complicated theories explaining this, but we still doesn't quite add up that light, something that has no measurable mass, is affected by gravity, something that has an attractive force only on mass, or why gravity affects time, something that has absolutely no mass or is a completely independent variable. And then I'll very briefly talk about the movement of light through the universe, but I'll then talk a bit more about this in another video I have prepared later on. So, the properties of light. The properties of a wave. Well, if we look at a wave, not light, but any simple basic wave, then a wave is a transfer of energy from one point to another without the transfer of material between the 2 points. A wave does not transfer matter. A wave transfers energy. And a wave travels through a medium. The speed of the wave is dependent on the density of the medium. So if the density of the medium increases, then the wave will slow down. If the density decreases, then the wave will speed up. And this is all basic physics that we already know. If we forget about the principle of light for the moment and just go back to basic secondary school physics and look at a wave through water or a wave through any matter, these are the basic properties. So, is light a wave? Well, light shows all the properties of waves except for a number of exceptions. The exceptions that I came up with just quickly is that light also shows properties of particles, or light-particle duality. Light travels through a vacuum in space, and the speed of light is always constant, whereas the speed of a wave isn't constant. The speed of a wave varies depending on the density of the medium it's traveling through. So those are three factors where light differs from being a wave. So that's partially why we believe light isn't just a wave, it also shows particle duality. So is light a particle? Well, light only shows a few properties of particles. It almost consistently follows every property of a wave, but when we look at it as a particle, well, light has no measurable mass, whereas a particle, by definition, a particle of mass would have mass. So we'd expect light to have mass, but it doesn't. Mass only travels at one speed, whereas any other particles can be motionless or would accelerate to a set velocity or decelerate if they stopped. Whereas light instantaneously travels at the speed of light. There's no motionless light, there's no accelerating light. So if we create light, automatically it's traveling at the speed of light, and that's no other particle displays this, whereas every wave displays this property. So even a small amount of energy, light instantaneously travels at the speed of light with no time for acceleration or deceleration. So it doesn't take a lot of energy to get light to move at the speed of light. Lighting a candle or hitting two stones together will make a spark. It's a very small amount of energy to get what could theoretically be a particle of mass to an extremely high speed. If we look at how much energy it would take to, say, throw a stone at the speed of light, it would take an enormous amount of energy. So that doesn't really fit with it being a particle either. And the other reason I think it's unlikely that light is a particle is if particles had mass and particles were moving at an extremely fast speed, then they would impact other objects if they hit them. So the light from the sun would be bombarding Earth like a machine gun as it would erode away everything in its path. So it has no measurable mass effect, and it has no impact when it collides with other objects. So again, there's a few reasons why I'm skeptical about whether light is in fact a particle. So no other particles that I'm aware of, and I can't say I know a lot of particles or experienced in the topic, but no other particles display these properties. So let's look at light in relation to space and what we theorize about space. If we believe that space is a medium of particles, then we can state that light is a wave that travels through a medium of particles or space. Therefore, we could state that light is a simple basic wave and nothing more, and that space is the medium of particles which the wave travels through. So now let's look at the same points above and see how that relates. So if light travels through a medium of space, if the light in this space, if the space is a medium, then light would have all the properties of a wave, because light would be a wave. Light could also travel through space, because space wouldn't be a vacuum, space would be a medium for all the waves to travel through. And light would also show properties of particles, because it is traveling through particles in space. So if we look at a wave traveling through water, it has all the properties of a wave, but it also has some properties of water, because it's a wave traveling through water. If we look at a wave traveling through jelly, then it has all the properties of a wave, and it also has some properties of jelly, because it's a wave traveling through jelly. So if we look at a wave of light traveling through space, then we would expect it to have all the properties of a wave, yet we would also expect it to have some of the properties of particles, because the wave of light is traveling through particles of space. So does light therefore have wave-particle duality, or is light just a wave that travels through particles? So I believe that light is a simple wave. Let's look at a simple wave. So here we have a medium. This is a medium of constant density. It can be a swimming pool, or a medium of water. It can be a medium of air. It can be a medium of jelly, or it can be a medium of space. So here we have a wave. This is a simple wave, a wave of water, a wave of sound. It's traveling through our medium, and as you can see here, this wave is traveling at 1 unit of distance over 1 unit of time. So as our medium is a constant density, we would expect our wave to travel at a constant speed, in a constant direction, and there's our wave travelling through a constant medium at a constant speed. Alright, so far so good. We've just got a simple wave travelling through a simple medium. If our medium was denser, then our wave will travel slower. So here is our denser medium. It's still travelling at 1 unit per second, but the unit or distance is now smaller because it's a denser medium. If our medium was sparser, then our wave would travel faster because our wave would still travel 1 unit every unit of time, but because the medium is less dense, the distance of mass is sparser and the wave travels faster. So I'm explaining this poorly, but most of you should already understand this concept. It's very simple. It's the basic principle of a wave traveling through a medium. Alright, the speed of a wave. If a motionless observer is in a motionless medium at a constant density, then all the waves will reach the observer at a set speed. Right? So here's our constant medium. It's a swimming pool. It's a pool of jelly. If we have an observer sitting in the middle, motionless relative to the medium, then if we create a wave, it will reach that observer at a set speed, regardless of the direction that it's coming from. All waves will reach the observer at the same speed. Make sense? Well, it should. So why is the speed of light constant? What does this have to do with the speed of light? Well, there are two parts to this question. Firstly, the speed of light is not constant. And before you all have a heart attack, I just want you to calm down, relax, let me explain myself. I know there's a lot of arguments against this. I know that current theory says the speed of light is constant, but I can explain to you exactly why we believe that shortly, so just follow me for a second. So the speed of light is not constant. The second point I'm going to make after that is that the speed of light appears to be constant because of how we perceive it in space, and I'll come back to that shortly. So bear with me. The speed of light is not constant. What are you talking about? Well, the speed of light appears to be constant to us because it is the same speed every time we measure it. But is it truly constant? The speed of light changes when the speed of light travels through a different density of medium. So as light travels into our atmosphere, the speed of light actually slows down because the atmosphere is denser than space. So the speed of light is slower in our atmosphere than it is in space, and that is a fact. We know that the speed of light travels slower through water. This is why light refracts when it hits water, and that's why we see objects in water at a different size and a different location, because the speed of light is slowing down as it hits the water and it's refracting. So the speed of light travels through glass. That's why we have glasses, that's why we have magnifying glasses, that's why we have microscopes. And the speed of light travels through plastic. In fact, the speed of light travels at a different speed depending on the density of the medium. So, if the speed of light isn't constant on Earth, then maybe the speed of light is constant in space, because space is a vacuum, right? So that's why we think the speed of light is constant. But is it constant? I don't think it is. If the speed of light is not constant on Earth, then it must be constant in space. But light curves around the sun. Light is pulled in by gravity. It is also slows down and stops due to a black hole. So if light is affected and bends due to gravity and slows down at a black hole, then the speed of light is not constant. And yes, I know there's the theory of relativity and we think that time changes, but if a single person in a single time observes a single beam of light to slow down in his time and not the light's time, then that light, regardless of what time it is in, is still slowing down. So whether you believe that the speed of light is constant or not, we still observe light to slow down on Earth, and we still observe light to slow down in space. So I argue that the speed of light is not constant in space or constant on Earth. And the fact is, I believe the speed of light is not constant, full stop. So, why do we believe the speed of light is constant? If the speed of light is not constant on Earth, and the speed of light is not constant in space, then why do we believe the speed of light is constant? Well, we believe the speed of light is constant because every time we measure the speed of light from space, it is travelling at the exact same speed. Yet we know that every object in the universe is moving at a different speed in a different direction. So how can an object be moving at a different speed in a different direction, yet every time we measure the speed of light, it is travelling at the same speed? The only logical explanation for this would be to say that the speed of light is constant. Correct? That is why we believe the speed of light is constant. However, we have no explanation or no good explanation of why the speed of light or how the speed of light could possibly be constant for everyone all the time, regardless of gravity, regardless of relative movement. So how do I explain it? Well, that's a good question. I can explain it with my current theory. So let's look at the concepts so far. Let's look at space, let's look at light, and let's look at waves. Alright, so let's look at a wave as it travels through a medium. If a wave travels through a constant medium, then it will travel at a constant speed, right? As the density of the medium changes, so too does the speed of the wave. If the density increases, the wave slows down. If the density decreases, the light speeds up. So why is the speed of light constant? Alright, well, if we consider that space is a medium, then the density of space, and if we considered that space was a medium and we stated that the density of space was constant, then the speed of a wave would also appear constant to an emotionless observer. So if we measure the speed of light from Earth, and Earth was in a constant density of space, and Earth was not moving through space, then the speed of light would be constant from every beam of light that we measured from every direction. So far so good. So there's a lot of what ifs here, but let's say this is space. It's at a constant density, it's motionless. Here we have our Earth, it is motionless in space. If a beam of light hits us from any direction, the beam of light will reach us at the same constant speed, regardless of the direction it is coming from, regardless of the speed or distance or direction that the object it came from is moving. So far so good? Yes, I know there's a lot of what ifs, but if the Earth and everything in the universe is moving, how does the speed of light remain constant? So why is the speed of light constant? If the Earth is moving through space, then the speed of light would change depending on if we were moving towards or away from the light, right? It's the simple Doppler effect. If we're moving towards an object, we would expect the waves of light to get shorter or move faster. If we were moving away from an object that emitted light, we'd expect that wavelength to be longer. We'd expect the Doppler effect to slow that wave down because we're moving away from the light. So how can the speed of light be constant? Well, here's Earth, and Earth is moving through space. What's going on here? So here we have space. Space is motionless. The density of space is constant, but our Earth is moving rapidly through space. Then, if we measure the speed of light as we're moving towards it, it would be faster, and as we're moving away from it, it would be slower. It's the Doppler effect. Light moving horizontal to the movement of the Earth would still be the same speed. So, depending on if Earth was moving through space, and waves of light traveled at a constant speed through space, then we would expect that we would be moving towards, the light we're moving towards would be moving faster, and the light we're moving away would be slower, and we would be able to determine our direction of movement in the universe. But we can't. So why is the speed of light constant? We come back to the same question. If we were not moving through space, but instead floating in moving space, then as the density of space remained constant, the speed of light would also reach Earth at the same speed. So what I'm saying here is that, yes, we are moving through the universe, but space is a medium, and space is also moving through the universe. So we are motionless relative to space. Therefore, if we are motionless relative to space, then the speed of light from every direction will be reaching Earth at the same time. And as space and Earth move together, the speed of the waves reaching Earth will always remain constant because space is not moving relative to Earth. Does that make sense? I hope so. Let's keep going. Why are objects motionless in space? Well, again, we've got another big call. How can I say that space is a medium and that we're moving with space and that Earth is motionless to space? Well, let's go back to my initial concepts and theories. Let's look at the ring model. Well, firstly, this can be visualized in two ways. Firstly, we can look at it on a local scale. We can look at our Earth relative to the Sun, relative to the solar system, relative to our galaxy. We can also look at it on a universal scale and how mass on a whole moves through the universe. So, this is the ring model. This is the shape of our universe. This is how all the mass in our universe is moving at a set moment in time. If we believe that space is in fact a medium of mass, then we can say that our entire universe is made up of space. So not only are these objects of mass planets, solar systems, galaxies and black holes, but these objects of mass are also particles of space. And this is a continuum. It's not individual objects of mass, it's a continuum of space in the form of particles from inside to outside. So the space inside the universe is denser than the space outside the universe, or at the peripheries of the universe. So then, if we look at an object of mass like our Earth, our galaxy or our solar system, or the space surrounding our Earth, then you can see that they move in rings or a continuum outwards. So as this moves outwards, so does the mass on the outside of it, so does the mass on the inside of it, and so does the mass on either side. So all the mass is moving outwards together. Therefore, the surrounding space or continuum of mass is all moving together, yet motionless relative to each other. It's expanding as a motionless mass of expanding gas. So the ring model. The universe is expanding in the form of space. Mass in the universe is suspended in space. Therefore, as the universe or mass of space expands, the objects of mass floating in it move outwards with it, or motionless relative to it. So this is getting a bit confusing. How can we simplify this a little bit? So the objects of mass remain motionless in the surrounding space. So here's our ring model again. That's just what I was saying before. This object is motionless relative to the objects around it. They all expand outwards, so they're all moving together. Mass isn't moving through space, mass is moving with space. So let's compare this to a moving river. If we imagine a moving river, then a boat can float down a river motionless relative to the water. So the boat is just floating in the water. It's not moving, no one's driving the boat. Yet because the river is flowing, the boat floats in the water, the boat is moving. The boat is moving motionless to the water because the water is moving with the boat. As the river narrows, the flow of the river will speed up, and the boat will begin to move faster. The boat still is not moving through the water, but is floating on the water and moving and motionless relative to the water. But the speed of the water is moving faster and the boat is moving faster. If the river widens, then the flow of the water will slow down, and so will the flow of the boat. The boat is still motionless relative to the water, but the water is moving slower, and so the speed of the boat is slower as well. So here we have our river. Here's the wide river where the flow of the water is slow, and as the river narrows, the flow of the water speeds up. Our motionless boat is just floating on top of the water. As the boat is in a wide section of the river, it is moving relatively slowly. As the flow of the river speeds up, so does the speed of the boat, and as the river gets faster, the speed of the boat gets faster as well. So here we have three objects of mass floating in a medium. As the medium accelerates, so does the objects of mass suspended in that medium, and the third boat moves away from the other two boats. Each boat is moving away from each other, yet each boat is motionless in the surrounding medium. This is exactly the same as our ring model, where each boat or each object of mass is suspended in a medium of mass, and that mass is motionless relative to the medium, and that medium is accelerating away. So, the 3 boats are floating in the river. They are all motionless relative to the water. However, all 3 boats are moving at different speeds. The first boat is moving slower, and the last boat is moving faster. Therefore, all boats are moving away from each other, all boats are moving at different speeds, yet all boats are motionless relative to their medium, the water. So, according to the ring model, a similar concept is happening with the objects in space and the universe. All objects are motionless in space, but as the universe expands, different objects suspended in different parts of space are moving at different speeds, yet all objects are motionless in space. So that all objects are moving away from each other, but all objects are motionless relative to the space they are in. So here's our ring model. I know I've done this before, but let's say it again. Here is our diagram of the river. As the river gets wider or the particles of space move further away, the velocity speeds up, and we can imagine each object, each galaxy, each universe, or not each universe, each planet, each solar system, or each boat as a different object of mass. And as the mass moves further out, or the flow of the space speeds up, each object also speeds up, moves away from all surrounding objects, but remains motionless in its surrounding space or medium. Alright, I hope that makes sense to some of you, because that's about as clear as I can explain it. You might have to watch that again if you don't get that, but bear with me, we'll keep going. So as space is affected by gravity, so that is how objects of mass remain motionless in the universe. However, on a local scale, it's a totally different story. As space is affected by gravity and the gravitational force of the Earth is constant, the space surrounding Earth will always be at a constant density. Therefore, as the space around Earth is motionless to Earth and at a constant density, the speed of light will always be constant from Earth. So let me explain that a bit more simply. If we have Earth and the surrounding medium of space, which is a medium of particles, these particles are also mass, so they're also affected by gravity. As the gravitational force of Earth is constant, because we have a constant mass at a constant density, then we are drawing in space, and the space surrounding Earth will be a constant density. So, if space is moving and Earth is motionless in space, and the space around Earth is a constant density, then all waves, regardless of what they are, including light, will move at the same speed when they reach Earth, because they're traveling through a constant medium at a constant density and are motionless relative to the observer. Alright, onto a local scale. Yes, the Earth has a constant force of gravity, but Earth is moving relative to the Sun. Earth is moving relative to the solar system, and Earth is moving relative to our galaxy. So, on a universal scale, sure, space and objects in space are motionless, but on a local scale, how can everything be moving and yet Earth still be motionless relative to the surrounding space when it's moving relative to the moon and relative to the sun? That's a good question. Earth is moving relative to the sun is moving relative to the galaxy. How can objects be motionless in space if all objects are moving? This is because space is a medium of particles that is affected by gravity in the same way as all other objects in space. So just as the moon orbits the Earth due to gravity, so too does the space surrounding Earth and surrounding the moon also orbit Earth due to gravity. So the space around our sun and galaxy are also orbiting these individual masses. So we have multiple orbits, and space is orbiting due to gravity, due to the force of the gravitational effects of each mass. Therefore, even though we're moving around the sun, we can still imagine that we're floating in motionless space, as the space around Earth and the space around the sun both orbit the sun. So, we can therefore think of space is relatively motionless compared to Earth, and that space around Earth is not moving. Therefore we are relatively motionless in space as Earth and the space surrounding the Sun orbit together due to gravity. For example, we can think of our solar system or objects in our solar system as floating balls in a bathtub. As the water flows down the drain, the balls orbit the plug hole due to gravity. The balls are not moving relative to the water, but floating in the water, and the water is drawn down the plug hole due to gravity. Floating balls are motionless relative to the water as the water circles the drain. The balls are motionless relative to the surrounding water. So, here we have our bathtub of water, and we have some floating balls in the bathtub. We pull the plug, and the water circles the drain due to gravity. As the water is pulled in, it goes down the plug hole. The balls are motionless in the water, but because the water is circling the drain, the balls also move around the drain, just like the moon orbits the Earth and the Earth orbits the Sun. It stays motionless in space as the space is drawn in by gravity and orbits the gravitational force. So space is a medium. We can think of space as a medium of particles just like water in a bathtub. If space is a medium of particles, then it is also affected by gravity and would orbit objects like the Sun, the Earth and the Moon due to gravity. Therefore, even though the Earth is moving relative to our solar system, our galaxy and our universe, it remains motionless to the surrounding medium of space. Therefore, the speed of light appears constant. So, let's summarize that. Why is the speed of light constant every time we measure it from Earth? The speed of light is constant every time we measure it from Earth because objects in the universe are motionless relative to the moving space as the space of the universe expands. Objects on a local scale are motionless in space. If space remains a constant density and a wave is a medium traveling through a constant density, then a motionless observer relative to the medium will observe all waves to be traveling at the same speed. Therefore, even though the universe and all objects in the universe are moving, objects can remain motionless relative to surrounding space. As the force of gravity surrounding Earth is constant, so too will the density of space surrounding Earth also be constant. Therefore, if Earth is motionless in space and the density of space remains constant, then a wave traveling through a medium will travel at a constant speed. The speed of light will always travel at a constant speed when measured from Earth. And so here's our diagram again. We've got space, the space is moving, Earth is moving with the space or motionless relative to the space. The space around Earth is a constant density, so all waves traveling through the medium of a constant density are traveling at a constant speed, and all waves measured from Earth will appear to be traveling at a constant velocity. Whew. Okay, hang in there, we're doing well. Why do we believe the speed of light is constant? Well, I've just explained it. Let's summarize again. We believe the speed of light is constant because it is always moving at the same speed through space when measured from Earth. This is because light is a wave, space is a medium, Earth is motionless relative to space, space is a constant density around the Earth. Therefore, the speed of light is always traveling at the same speed measured from Earth because a simple wave traveling through a constant medium will always be the same speed to a motionless observer. Therefore, we assume that the speed of light is constant. But the speed of light is not constant because the speed of light changes as it changes through a medium of differing density. Therefore, the speed of light changes, and we know this is true through this as it enters the atmosphere, as it goes into plastic, as it goes into glass, or as it goes into a medium of changing density. The speed of light also changes due to gravity in space, and depending on the density of that space due to gravity. Therefore, the speed of light is not constant, and will travel at different speeds and different densities of space. Okay, so we now have a simple concept which clearly and accurately explains why light can follow all the characteristics of a simple wave and simultaneously accurately explains why we perceive light to travel at a constant speed in space relative to Earth. So this concept shows us that light can be a simple wave and appear to be constant, and exactly how it does that. Using the same principle, we can also account for the other properties or phenomena of light that we observe from Earth. For example, we can also explain why light bends due to gravity. So why is light affected by gravity? If light has no measurable mass, and gravity is a force which solely acts on mass, then why would light be affected by gravity? Well, if space is a medium of particles, then space will be affected by gravity. So the space around an object with a large gravitational force will be drawn in by gravity. Therefore, the space around a gravitational force will be denser than the space further away from the gravitational force. So a wave slows down as it travels through a denser medium. If light is a simple wave, we would expect it to slow down as it travels through denser space. The space is denser around large masses with a strong gravitational force, so light will slow down in denser space around a large gravitational force. So here we have space, or a medium. It's evenly distributed. It is a constant density. However, if we put a wave of light or a wave through our medium, it will travel at a constant speed of 1 unit per time. Now, if we change the density of our medium by putting an object of mass or a strong gravitational force, then we can see that the particles of space, or our medium, is affected by gravity, and the gravitational force of Earth pulls in particles of mass in space. So the space around Earth is denser due to gravity than the space further away from Earth, which isn't affected by gravity. So if we now put a simple wave through a medium of changing density, then as the density increases, the wave will slow down, and the wave will also bend towards the increasing density, because it's traveling slower in the denser medium and faster in the sparser medium, so it curves or bends towards the gravitational force. Therefore, as the light travels closer to Earth, the waves of light slow down, the wavelength becomes shorter, and the direction of the wave curves inwards due to the changing of the density of the space. As the light travels further away, the density of space decreases and the light begins to speed up again. This is as opposed to what we would expect to happen if space was a true vacuum, where if the density of space was constant, then we would expect the direction and velocity and wavelength of any wave, including waves of light, to travel in a straight line. But if the density of the medium which a wave travels through increases, then we would expect that wave to slow down, shorten, and travel towards the increasing density. So light and gravity, sorry, we'll get rid of that. So as the density of space increases due to the force of gravity, the speed of light slows down. This causes the light to bend towards the gravitational force. Even though light has no measurable mass, it is still affected by gravity because the gravitational force is affecting the medium in which the waves of light are traveling through. If light heads towards a black hole, then the density of space increases due to the force of gravity. As the density of space increases, the speed of light slows down. The density of space is so dense it can stop the movement of light surrounding a black hole. This is why light appears to stop inside a black hole, but this is also why light bends and slows down as it nears a black hole, and also as it reaches Earth and this is why the speed of light then speeds up as the density of space decreases, and it still reaches Earth at the same speed because Earth still has the same density of space surrounding it. So the speed of light can slow down as it nears a black hole, and as it travels further away, it will speed up again, still reaching us at the same constant speed. This is because as the light passes the black hole, the density of space decreases. As the density of the space around the Earth is constant, the waves of light will have sped up and be travelling at the same constant speed when it reaches us on Earth. Regardless of its previous speed or direction, the speed of light will always be constant around Earth. Alright, so now we understand why the speed of light appears to be constant around Earth. We also understand why the light appears to change speed and direction due to gravity. We can therefore explain the behaviour of light as it nears and enters a black hole, and also as it leaves or passes close by the black hole but then reaches us on Earth. All the same simple concept, all while maintaining that light is just a simple wave. We can also begin to understand other things like due to space and light, like the movement of light through the universe. I'll just cover this briefly and I'll talk about it more in a later video, but what I'd like to say here is that what we see in space and what we perceive through light in space is not always the same as what it really is. So, this also changes how we perceive objects in space. We can only perceive objects in space through light as it reaches us on Earth. However, the light may have been manipulated prior to reaching us on Earth. So just like the black hole, the light may have been travelling at a slower speed, it may have been curved due to gravity, but by the time it reaches us on Earth, it is always reaching us at a constant speed, at a set velocity. Therefore, the light that we see may have been manipulated from where it originated from, and what we actually see may be quite different from the true object. For example, we perceive that the light travels in a straight line at a constant speed, but if the light was travelling slower or bent around a gravitational force, then the true size, speed, location, or any variable that we measure in space may have been different or manipulated from the true value to what we then perceive. So here's an example. Here we have a star floating in space, or an object which creates a wave, say a boat sitting in the water. If the medium which it's travelling through is a constant density, then the wave will travel in a straight line at a constant speed, and the observer will observe the wave from the object as a true value or unmanipulated value. So the observer will observe this star to be this size at this distance travelling at this speed. However, if a gravitational force affects the density of space, or anything affects the composition of space, then what we see and what we perceive may be very different from the true value. For example, here we have a smaller star which is closer to us and further to the right. It's sitting behind a large gravitational force. This star creates a wave of light, but this wave of light is travelling slower and is travelling in a different direction. It bends due to gravity, and as it moves away from the gravitational force and towards the observer on Earth, the consistency or the density of space decreases to the same constant density of space that Earth is surrounded by. And therefore, what the observer on Earth sees is different to the true value. The observer would perceive that the beam of light was travelling at the same constant speed in the same constant direction. Therefore, the observer would perceive a larger star further away in a different location. If this smaller star was moving slowly, the observer would perceive that star to be moving faster than it truly was, because the observer can only perceive that star through the waves of light that reach him on Earth, not the waves of light anywhere prior or between the object that is creating the waves and the observer. Only the waves as they reach the observer. Does that make sense? Alright, so let's do a quick summary. Or, not so quick summary, let's do a proper summary. Light. Light can be better understood if space is a medium. Light is a wave in every way apart from two factors. Firstly, light can travel through a vacuum of space. And secondly, it also has the properties of particles. Therefore, if space is a medium of particles and not a vacuum, then this would explain both of these phenomena. Space could simultaneously have all the properties of a wave, could travel through space, and also demonstrate properties of particles, as space would be the medium of particles in which light was travelling through. Therefore, light may not exhibit wave-particle duality. Instead, light may just be a simple wave that travels through a medium of particles in space. Just like a wave in water shows properties of a wave and properties of water, a wave of light in space shows properties of a wave and properties of space, or properties of particles that make up space. As light travels throughout space, there are particles throughout space. So that means that our universe is full of particles of space. It is not an empty vacuum, but in fact entirely full of mass in the form of space. Light. If we start thinking of light as nothing more than a simple wave that travels through a medium of space, then we can go on to explain a number of other phenomena. For example, if space contains particles, then space will be affected by gravity. Therefore, the density of space will increase around a large gravitational force. A simple wave slows down as the density of that medium it travels through increases. Therefore, we would expect that the speed of light to slow down around a large gravitational force, which it does. This is exactly what we see when light passes near a black hole or a large gravitational force, like the sun. Current belief is far more complicated. It uses a theory that time slows down around a black hole and that true distance and true time are variable, whereas the speed of light is constant. This is an alternative theory, which is also accurate to all observed facts and phenomena, and it just says that the speed of light is not constant. Therefore, I suggest, and I'll talk about this later, that the speed of time and true distance are constant variables which can't be manipulated. So what is manipulated is the speed of light, and because we misperceive that the speed of light is constant, we misperceive that we're accurately measuring or have a perfect measure of time. So if distance equals time or velocity equals distance over time, if the velocity is variable, then the distance and time can change. However, if velocity is constant, which is current belief, then the distance and velocity must be manipulated. I'll talk about this more in another tutorial because it's getting a bit much for this one. Anyway, this could also be true about why gravity, an attractive force between mass, can affect the speed of time, a variable that has no mass. So why would time, a man-made construction to measure the passing or the time between two events, be manipulated by gravity, something that has no effect, or theoretically no effect or relationship to time? Time has no mass. Gravity is a force that acts on mass, so why would gravity affect the speed of time? Therefore, if we state that space is a medium, then not only do we have a far more simple explanation of how light can travel through space in the first place, but we also have an explanation of why light slows down due to gravity. So the speed of light. The speed of light is believed to be constant, but light slows down as it passes through a denser medium. The speed of light slows down when it goes through water, glass, plastic, or even our own atmosphere. So, why do we believe the speed of light is constant? We believe the speed of light is constant because we know everything in the universe is moving in a different direction at different speeds. Yet, when we measure the speed of light as it reaches us on Earth, it is always going to be the exact same speed. So until now, the only possible explanation, or the only reasonable explanation that could justify this phenomenon would be to say that the speed of light is constant, even though we know that that is not true. We know that the speed of light is not constant on Earth as it travels through different mediums, and we know that it's not true in space when it passes a large force, gravitational force like a black hole, a galaxy, or a planet or star. So even though we have no idea how it would even be possible for the speed of light to be constant, and even though we know that the speed of light isn't constant, we still strongly believe that the speed of light is constant. And I believe this is inaccurate. So why does the speed of light appear to be constant from Earth? This is because light is a simple wave traveling through a medium of space, and that the Earth is motionless relative to the surrounding space. The Earth has a constant gravitational force, and so the density of space around Earth is constant. A wave travels through a constant medium at a constant speed, and the Earth is not moving relative to the surrounding space. Therefore, the speed of light is constant when it reaches Earth, regardless of the speed or direction of the object that emitted that light. This is why the speed of light appears constant from Earth. This is a theory which is simple, that space is a medium, that Earth is floating in space. It follows all the rules of science that we already know. It can explain all the phenomena of light as a simple wave, which we already well understand. And it can also simply and accurately describe why the speed of light appears constant and how it is possible for the speed of light to appear constant. None of which can be done by current theory today. All our current theories are complicated and unrelated, and they have no good, adequate explanation for why the speed of light would appear constant from Earth. So, the speed of light. But if Earth is moving and all objects in the universe are moving, then how can objects be motionless in space? The answer can be looked at from a local scale and a universal scale. On a universal scale, the universe expands and moves as demonstrated by the ring model. As space is mass, and the rings of mass in the ring model are also move with the surrounding space. So the rings in the ring model are a continuum of mass from inside to outside. Space is mass, so space moves with all other mass in the ring model. In other words, the universe is expanding because space is expanding. Objects like the solar systems and galaxies are suspended in the expanding space, or motionless relative to space. On a local scale, the Earth is moving relative to the Sun, to the Moon, and to the solar system and galaxies. But the Earth is moving due to gravity. If space contains mass, then space is also affected by gravity in the same way that the planets, the Moon, and stars in our galaxy also behave. Therefore, the space around Earth is orbiting Earth like the Moon, and the space around the Sun is orbiting the Sun just like the Earth, and so on. Therefore, the Earth remains motionless in space as it floats in the surrounding space which is rotating or orbiting the Sun. Therefore, we can explain how the Earth remains motionless in space, despite knowing the Earth is moving relative to all other objects in the universe, and despite knowing that the universe is expanding. We can therefore explain why the speed of light appears constant from Earth. Space versus true vacuum. Okay, so let's go back to the beginning again. So it is currently believed that space is a vacuum. However, there is no conclusive proof that it is, and nothing has excluded the possibility that it cannot be a medium of particles. There are also multiple phenomena which suggest that it is a medium of particles. There is no negative pressure or vacuum in space. It transmits waves like electromagnetic waves, radio waves, GPS waves, waves of light, waves of heat, waves of radiation. It has a temperature and a background energy, which can more simply be explained by saying that space is a medium of moving particles than by some extreme theory that the Big Bang left a background radiation throughout all the universe 14 billion years ago. Both theories are possible, but my theory is much more simple, much more logical, and would accurately explain why space appears to have an energy and a temperature, as opposed to if space was a true vacuum where we would expect it to have no energy or no temperature. We also know that space is moving and that space is expanding and that our universe is moving. So if space was a true empty vacuum, then how can nothing move into nothing or move through nothing? There must be mass or particles or something to move or something to expand. Nothing can't expand. Space is also affected by gravity. This explains why light is affected by gravity. This explains why time is affected by gravity. This explains why light appears to slow down as it passes a gravitational force. And this explains why space appears to be motionless relative to Earth, or why Earth doesn't appear to be moving despite us knowing that Earth is moving relative to everything else in the universe. This also explains why objects in space orbit each other. So if space is a medium of particles, just like water is a medium in the bathtub, then as space is drawn in by gravity to large gravitational forces, it draws in other objects that are floating in space, and that's why objects orbit each other as opposed to moving directly towards each other as we would expect they would, just like objects on Earth. It also explains the creation of galaxies and the universe as it appears today. So if we imagine when the universe was created that it was purely a simple, rapidly expanding ball of space, then we can imagine that over the last 14 billion or trillion or however many years it's been, that as particles of space begin to combine due to gravity, they increase in mass. At a long enough time and enough particles, you can create a physical object of mass in space as the particles accumulate due to gravity. As particles like dust and planets and solar systems and galaxies increase in size, so does their gravitational force, and so does the speed which they draw in particles of space. So you can imagine that the Earth, the Moon, the Sun, and our own galaxy are continually drawing in space due to gravity. So all objects in the galaxy are increasing in mass as they draw in more particles of space. Over a long enough period of time, you then begin to create stars, planets, black holes, and galaxies themselves as the precipitation of particles in space accumulating together due to gravity. So that's where galaxies come from. Galaxies have been created over time due to particles of space accumulating due to gravity. And it also explains why light slows down due to gravity. It also explains the properties of light and why it behaves the way it does, because we can now believe or think of space as a medium, and then we can think of light as a simple way of travelling through that medium. So we can understand why light appears to be travelling at a constant speed from Earth. We can understand why light appears to bend or slow down due to gravity in space. And it also explains why the speed of light appears constant. So, the creation of the universe, going right back to the start now, if we now come back to the creation of the universe, if we believe that space is a medium of particles, then we can understand that outside our universe is a true vacuum, a vacuum with no particles, a vacuum that has a strong negative pressure, a vacuum which I call negative space. So this explains how the universe is created and why it is expanding, because if the universe is a mass made up of space, or space making up a mass, then outside our universe is a strong negative force acting to pull our universe apart, causing the creation of our universe, causing the expansion of our universe, and why our universe is expanding at a accelerated rate. These principles can now also accurately explain dark matter. So it has been discovered that almost all objects in space, including our own solar system and galaxy, are orbiting in a smaller radius than what we would expect for the calculated mass. Therefore, there is a large proportion of the mass in the universe which has been uncalculated or unaccounted for. Therefore, a large amount of the mass in our observable universe has not been discovered. It was then postulated that a matter exists outside of our detection, dark matter. Dark matter has never been discovered, but we know it is in our own galaxy. So let's look at the facts. We know that this matter contains mass, which exerts gravitational effects, which account for the orbit of our galaxy and our solar system and all the other galaxies in the universe. Dark matter is in our own galaxy. This matter does not emit or absorb light or electromagnetic radiation. Space fulfills all these requirements. Space contains mass, which is affected by gravity and has gravitational effects. Space is abundant throughout our galaxy and all of the remaining universe, and space does not emit or absorb light. Therefore, I believe that space is dark matter. What about dark energy? Well, dark energy is a concept created to explain the expansion of the universe. Dark energy has also never been discovered. However, if the creation and acceleration of the expanding universe is caused by the negative space surrounding our universe, then we have a perfectly sound explanation for the expansion and creation of our universe. Therefore, we no longer need a concept of dark energy, an entity which probably does not exist. Therefore, I believe that negative space is the reason our universe is expanding. Negative space is therefore the dark energy that we are looking for. So, coming together, here we go, the unified theory. So over the last few videos we have discussed a simple concept and used it to explain multiple phenomena regarding our universe. The simple concept is the relationship between gravity and a pressure gradient or vacuum that explains the creation of our universe, and it explains how our universe moves according to the ring model. It also justifies that the space in our universe isn't in fact a vacuum, but in fact a medium of particles or mass, and this goes on to explain many of the phenomena that we observe in the universe. So the ring model describes the shape, movement and distribution of mass in the universe over time. Using the ring model we can go on to understand that the universe is a large expanding mass in the form of space. We can then go on to explain what it was like prior to the creation of the universe, what is outside our universe, and we can explain the creation of our universe and why it's expanding. We can also understand other observable phenomena like the formation of galaxies, why objects orbit each other in space, and the existence of dark matter and dark energy. We can also explain the properties of light, why we perceive light to be constant, and why light is manipulated due to time and gravity and mass. So, there are currently multiple theories that explain many phenomena that we observe in the universe. Some of these theories are complicated, some of them only partially explain what we observe, some of them have no explanation for how these theories could possibly exist. The Big Bang Theory partially explains the creation of the universe, but it causes the breakdown of physics as we know it. There's no physical way that the Big Bang Theory could have happened. NASA theorizes that the universe is flat, yet we observe the universe in every direction we look. Einstein's theory of relativity is a complicated, intricate theory which explains that the speed of light is constant and that time and distance change, but it has no explanation for why the speed of light is constant or how that would even be possible. So, all of these theories leave many unanswered questions and often raise more questions than they answer. They do not appear intimately related or intermingle with each other, and they do not answer everything in a simple and clear fashion. So, alternatively, I have one simple theory which clearly explains everything that we observe in the universe. So, I ask you to keep an open mind. Just because you believe something to be true, is it not more logical to say that one simple theory which explains all phenomena is likely to be more accurate compared to multiple different complex theories which only partially explain some phenomena? Okay, so far so good. Now you're still following me. I hope I haven't angered too many physicists out there. I hope I haven't upset anyone or given anyone a heart attack. All I'm saying is that we have a simple theory that light is a simple wave It follows all the properties of a wave. It travels through a medium of particles. That's why it displays particle duality, and its space is the medium of particles in which it is traveling through. So here's our checklist. We have a single concept which is space is a wave, that light is a simple wave, that space is a simple medium in which the waves of light travel through. It's simple. There's no made up anything. It's not far-fetched. It doesn't fit with current theory, but it can explain all the observable phenomena, and it's not a difficult or complicated concept to grasp. It follows basic proven science. It explains why the speed of light appears constant. It explains how the properties of light behave in space. It fits with everything that we observe and everything that we measure. There are no complicated concepts, there's no undiscovered forces, there's no extras or additionals or things that we haven't discovered or don't already know. We're not using alternative dimensions. So, does it explain every observable phenomenon? Well, it begins to explain the universe. It explains how the universe was created, why it's expanding, the shape and movement of the universe. It explains space, and the properties of space, and why space has the characteristics that it does. Why space has a temperature, why space has a background energy, why space manipulates the path of light as it travels through it, and why space allows waves to travel through it full stop. Why light lets radio waves travel freely through it, or electromagnetic waves. It explains or accounts for the existence of dark energy and the existence of dark matter, explaining exactly what they are, what they're composed of, and where they are, and what we were looking for. And it also explains light, why the speed of light appears constant, why the speed of light is manipulated in space and due to gravity. What haven't I explained yet? I haven't talked about time. That's a big one, which I'll go on to in my next talk. Also, probably the biggest thing yet, which I'm very excited about, is to talk to you about gravity. I haven't yet talked to you about gravity, but this simple single theory I believe can accurately explain what gravity is, how it works, and why it works. In fact, this theory unravels the mystery of gravity, a theory or a concept that to this day still escapes our understanding. There's no adequate or reasonable explanation for the existence of gravity, and I look forward to talking to you about this one most of all. And then we still have a lot of phenomena that are observed in the universe which I haven't discussed as well. So, the unified theory. What phenomena have we not discussed so far? Well, over my next videos I'm going to talk about gravity, something I'm very excited to talk to you about, something that's not an extremely simple concept, but something that makes sense, something that's logical, and something that can accurately explain how gravity works and why it works. But in my next video I'm also going to talk a lot more about light, explaining exactly how we perceive light, and exactly how light is manipulated in the universe to explain things like why the universe appears homogeneous in every direction, yet the ring model states that the density of the universe increases as you move towards the center. And then I'm also going to talk to you a little bit about some of Einstein's theories, why they may appear to be true but may have some inconsistencies or inaccuracies. And then I'll discuss time and our current misperceptions of time as well. So thank you very much again for all your time, for all your hard work and effort. I appreciate you watching these videos. I know that you're all out there skeptical. I know that you haven't heard these concepts before. I know that everyone strongly believes current theories, and so I'm eternally grateful for you for watching these videos, for trying to keep an open mind, and to listening to an alternative idea which can also accurately explain many of the phenomena we observe in the universe. So if you're still interested, if you're still skeptical, please continue to watch my videos. The next video, video 5, will be time. And then for more information, if you've seen the videos, then I've published a book, you can get a free copy on my website. I haven't made the website yet, but it'll be available shortly. Or you can get an ebook on Kindle for only $3. That's the cheapest I can make it. Or you can actually get a physical hard copy of my book for only $10 from createspace.com. Just search for A New Universe by Mark Hatfull. Again, that's the cheapest I'd make it. If I could make it free, I would.